Next we have we are going to load this data in the form of stack locations. Like we know the push and pop registers are basically connected to the stack. So here we are utilizing R4 registers, and this R4 register is act like a temporary location pointer where the array of data is located with R4 and also linked with R3. So when you say R1, so R1 will have initially your first address, initial address, starting address of the program counter, and thereafter every character will be identified with the address which is linked with R3. So R1 will have your starting address, and the remaining characters will be identified with the address which is connected with R3 register. Again, we are going to push R4, that is whatever the data is being fetched one by one, it is kept temporarily R4. So as I told you, R4 is only a temporary location, and all the data is being connected to the R4 now. So we are going to compare the values in the temporary register R4. So whether it is equal to 0 or not. So if it is, what is the purpose of? So here we have already loaded this character from welcome to new horizon. So it will fetch one by one and it will link with the R4 register, and it is also connected fetched through from here starting address R1 and R3. So here, as I told you, it is kept in the R4 register. Now we are going to keep changing the character because initially it is W, then it is going to change it as E. So different characters are present in the string. So we are going to compare whether it is uppercase or lowercase. So to check that, we are using the register R4 and comparing it with 0. So if it is equal to 0, then we are going to the next condition, branch if equal. If it is 0, then it will go to finish. It means it will fetch the next character for comparison whether it is uppercase or lowercase. So the first condition is to check whether it is equal. Now next we are going to check with the next conditions, compare the string whether it is not equal. So if it is not equal, it will compare the string with the R4 register with a space. So once the space is detected, the processor will tell that it is going to switch over to the next word. Say for example, welcome, a complete string is over and we have a space created and next word is 2. So this will say if it is not equal, then it will say branch equal next character. It means the next word is going to be 50. So next is the main section, add R4, R4 has A minus A. So this is the instruction which is exclusively used for the conversion from uppercase to lowercase. So here this instruction, as I said, here we are getting add R4, R4 A. So as it is given A minus A, so this A will be keep on subtracting with 0, and then we are having the also the lower ASCII value of small letter A. So and then it will compare subtract with the have the difference between this lowercase value the lowercase value and the uppercase value, and then the difference value will be loaded into the R4, that will be taken as the lowercase equivalent ASCII value. The final result will be connected with your R4 and R2 and R3. Yes. As I said, it is only used for a temporary register to convert from uppercase to lowercase by taking the difference value between the lowercase with the uppercase ASCII value, and then it is connected to the R4, and we know already R2 is used for the designated memory location or the destination memory location, and then R3 will be incremented by 1. Now here this is to increment to the next character. See, if I don't increment R3, it means we are not going to move on to the next string value in this next character this complete string value. So we need to increment so that it will convert individual character from uppercase to lowercase. So you can get the result in R2. Okay. So this is what is done here. This instruction store or store byte R4, R2 and R3. So the end result is obtained from R2. So let us see the execution. So as I said, it is taken with the program counter relative to address. So it is loaded with this address, and R1 is having this temporary address where your welcome to new horizon equivalent ASCII will be present. So let us see. So the address is 0x08 0 is given here R1 1 F4. So this is the ASCII values of the uppercase letters what we have loaded in the capital. So welcome to new horizon. So it is calculated from W and you can see it directly. So space, as I told you in the previous experiment, space is for equal ASCII value is 20, and this is for T, this is for O, and this is for again for space. So now let us see how it is converted into the lowercase ASCII value, because all are uppercase letters, and your lowercase ASCII values are loaded in 2000 100. So R4, you can see that initially the first ASCII value of the uppercase letter is taken and put it on the stack. It is in 57. 57 is equivalent ASCII value for uppercase ASCII value for uppercase letter W. And then it is going to compare with 0. And then it is going to the finish. And then the next character has to be loaded. So it is going to now compare. So it is going to compare whether it is uppercase letter, and then it has to show the difference amount. First, initially it will subtract with 0. A will be subtracted with 0. Keep on subtracting 0, and then it will have the equivalent ASCII value of A and ASCII value of capital A. So the difference different of ASCII value of uppercase and lowercase will be obtained. So it goes on like this to fetch all the characters. So let us see. Yeah, we know that the end result is obtained from 200. This is the memory address used for the uppercase letters, but we want the converted lowercase ASCII values. So let us give the addresses 2000 100. So this is the lowercase ASCII values of the character welcome to new horizon. So this is an uppercase where we have seen 57 as for W, and that's for uppercase, and 77 is for lowercase. So this is how the conversion of uppercase to lowercase is done in ASCII values. So what we have seen is uppercase ASCII values are converted to lowercase ASCII values, because we are going to represent your character only in terms of